So the first thing to do is to download few images. So I downloaded the famous Lana image, which is basically a standard image processing test images. So yeah, the first thing you need to do is to read this image from the source. So I'm going to declare image, which is of type matrix. MAT corresponds to matrix. Now we need to do a bunch of operations before we transfer this image. So I'm going to set this as image source, image basically grayscale. So I'm going to just say GL, which has been transformed from color image to a grayscale image. And then we're going to declare one more called the image destination, or the final image which you're going to get. So this mat type, it holds the image in a matrix form, and then it also holds the type of the image, like it could be monochrome or grayscale. Like it holds all these properties which are required. All right, so I'm going to read this image. So image underscore source equals IM read. So now that we have read the image, we need to make sure that the image is read in proper. I mean, if not, we have to just throw an error. It's like a security thing to make sure everything's working fine. So if not, image underscore source dot data. So if the data is being read, we're gonna be processing it, else we can just throw an error, return -1. So if we fail to read the image, we can just gonna return -1. All right, so now that we read the image, let's just see if this image is being read or not. So I'm gonna make a new window. I named it named window. Let's just call it as our source image, and I'm going to display. So let's just set the window size to automatic. So OpenCV picks this size by itself, so don't worry about it. So IMShow will display the image. So so when do we end this function? Just say wait key until any key is pressed. So that's gonna be our, so this is gonna exit the program when we press some key. All right, just let's run this thing. All right, so the image is here. So this is a source image. So I'm just gonna click return. It's gonna conclude this thing. So now we need to transfer this image to a grayscale. To do that, we're gonna use a function, OpenCV predefined function called CVT color, and then we're going to transform it. So CVT color, you just give the image source, image underscore source, and then your destination, like where you want it to be transformed. So that's going to be grayscale, and then you tell the type of transformation C underscore V, blue, green, red to gray. Where is that? So this is going to transform to RGB, but we need a gray, so I'm just going to say it as BGR2. Oh yeah, there we go here. So this is going to transform the image from color to a monochrome. So we can copy the same thing and we can paste it to a new window. I'm going to say it as image underscore grayscale. That's gonna be okay. I'm gonna just copy this thing and paste it, and this is gonna be our image underscore GL. So this is gonna transform the image from monochrome to from RGB to grayscale. So this here is our grayscale. This was a source image. So source image to grayscale. So this has 3 channels, or for each pixel it has red, green and blue, and this for each pixel it has a single scalar value varying from 0 to 55. So my plan is to apply the the kernels on this image. So I mean, we can apply the kernel on this image too, but we can see computationally it's much more easier for you to understand. You can always apply the kernel to this thing. All right. So now the kernel part. So for defining a kernel, I'm going to write a function. So I'm going to call it as sharp and sharpen. So my first kernel is going to transform this image. It's going to sharpen the image based on the source image. So I'm going to give a constant because of type CV matrix, and I'm going to pass the address of the image. And then I'm going to send the address of my result image too. So cvmat ampersand res. Let's just call it result. So this function is going to take an image and then it's going to transform it to something else, and then we can, and then it's going to put the result in the result pointer, and we can read the final image. So to construct a kernel, we're going to build a new matrix. So mat, I'm going to call this as kernels, Kernel, kernel. So let's just, okay, cool. It doesn't really matter. I mean, you can just pick. So the dimension or the size of the matrix is going to be 3 cross 3. It's a 2D matrix of 3 rows and 3 columns. And the type of values will be CV underscore 32F. That's going to be 32-bit floating point numbers. So we will initialize all the values to a scalar 0. So CV, CV and then scalar scalar 0. So this is going to build a new matrix called kernel of 3 cross 3 and set up all the values to scalar 0. So now we need to assign the values to this kernel. So I have built a, I'm just going to copy paste the values from a documentation. So here, so this operation is going to basically set up the values at the floating point. This is the index. So in the matrix 3 cross 3, we're going to set up row 1, column 1 to 5, row 0, column 1 to -1. If you have, like when we did the workout before, we set up these values in matrix. So that's the same bunch of values I'm just going to put in the kernel. Alright, so once the kernel is set up, we're going to call this function called CV filter to the. So we need an image source that's going to be our img image, and then we need a destination source that's going to be result, and then we need depth of the image. So in case of color image, the depth is going to be 3, that is RGB 3 channels. In case of monochrome, the depth is 1, that is because of single pixel values, right? So to get that, we can just say source image dot depth. So that's going to give the depth value, and then the kernel values, whatever kernel we want to apply. So I'm going to call it as Kernel kernel. So yeah, so okay, the return type is that's the void. So when we call this function, it's going to take a source image, it applies the kernel. The function is basically doing the same transformation which we discussed earlier, and then that's going to be set up in the result, and we can display the result. Alright, to call this image, just copy this function kernel and then send your source image, that's your image underscore source, and then your destination image, so image underscore dst. So yeah, so we pass 2 variables, that's it. So when we call this function, that's gonna be holding the final, right? So I'm just gonna copy this thing and paste it again. I'm gonna say it as sharpen, it's HARP. P-E-N-E. So this is going to be DST. All right, let's just run this thing. All right, so we have 3 images. So this was our source image, and this was our grayscale image, and this is a sharpened image. So you can compare both of them. This is the source, this is the destination. So it has been sharpened. Oh yeah, so this sharpen function is being applied on the color image, because that's what the values we passed. So I'm gonna change this value. So instead of passing the source, I'm gonna pass GL, the grayscale image, and see how it works. So in this case, the depth will be 1. So this is a sharpened grayscale. This is source grayscaled. So I'm gonna do one more kernel. So there's a kernel called what was it called? Let me just see. Oh, top Sobel. Okay. So the top Sobel kernel, it's something like, it highlights the feature like edges and stuff. So so I'm just gonna make a new. I'm just gonna copy the function I defined earlier. Let me just copy it. Okay, so I'm gonna copy this whole function, and then call this function as Sobel. So I'm just gonna change the kernel values. So I'm gonna remove all this values before, and then paste a different matrix. So this matrix has these values, like the index 0, 0 is going to be -1, 0, 1 is -2, 0, 2 is -1, and the middle row is like 0, 0, 0, and the last row is +1, +2, and +1. So let's see we apply this function on the source image and see how it looks. So instead of sharpen, I'm going to call it as Sobel, and I'm going to apply it on the source image. Let's say source image. This is going to be image Sobel. All right, let's see. For some reason, the image is being transferred to my other window, so I have to pull it all the time. So that's the source image, and this is being transformed to the top Sobel. You can see like how the feature has been highlighted. Like you can see all the edges, and the main features is being boosted up. Like if you look around the eyes, it's like more boosted up. We can do the same thing for grayscale. That's GL. So yeah, so that's how the image kernels work. I mean, like you can like Google for different kernels, like the bunch of different matrices. You can like use this as a sample code, and then you can modify the matrix, and you can apply this transformation. All right, so in the next video, we're going to use this logic to extract from features, or maybe like we can think of something else. I was thinking like maybe apply like a Gaussian filters or a bunch of different filters, so we can understand how they work. I mean, like you do all this process to basically extract basic features. Like ultimately, let's say you're gonna build a like a face detection algorithm, so you're gonna use all these filters to extract features. So this is like the very important concepts to learn. All right, see you in the next video. So make sure you guys subscribe and give me what you think. Like give me your comments on what you think.